Hey guys, so here is the chapter 12 study guide. So I wanted to go over this with you exactly as you have it. So for number one, for 2 weeks, Mark recorded the color of the traffic lights, and the results are red, red, green, green, red, red, yellow, 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 yellow. Make a frequency table for the data. So then we've got 1, 2, red, 1, 2, green, 1, 2 more red, 1, 2 yellow, and then 2 more yellow. And that is a total of 4, 5, 6, 7, 8, 9, 10. So there's 4 here, 2 here, and 4 here. Okay. All right, looking at number 2, it says use the frequency table to find the probability that a person goes to the movies at least 2 times a month. This means it can be 2 or 3 or 4 or more. Okay, so we can go up and up and up and up. So we're going to start at 2. This one says less than 2. So we are looking at this one and we are going up. So we're going to do 217 plus 173 plus 106. And that's going to be all over 710. All right, so then I don't know if this calculator, I'm going to pause real quick. Okay, so I went ahead and grabbed the graphing calculator and I put the numbers in, added them, and that gives me 496. So I have 496 out of a total of 710. So I'm going to divide that by 710, and that gives me 0.6985. And it says round to the nearest thousandths. So we're going to go to 3 places. 6985. 5 tells me to go up. So this is 0.699. Okay. Looking at number 3, a dartboard has 8 sections of equal area. The letters represent the colors red, yellow, blue, and green. Use a table to show the probability distribution for a dart that hits the board at a random location. We have a total of 8 wedges. So everything over here is going to be over 8, and it might possibly be able to be reduced. So looking at red, I have 1, 2, 3, 4. So that's 4 out of 8, which that is going to then reduce to 1/2. For yellow, I have 1, 2, and 2/8 reduces to 1/4. Green, I have 1, and blue, I have 1. So then my probability distribution would be 1/2, 1/4, 1/8, and 1/8. Okay, looking at number 4, this matches what we did before Thanksgiving in the 12-1 assignment. And I think this was like number 11. I cannot remember 100%. The table shows a simulation to predict how many cars will arrive at a car wash. Each event represents how many cars arrive during a 10-minute period. Use the 6 randomly generated numbers, and so they are giving us those 6 randomly generated numbers to predict how many cars will arrive over a 1-hour period. So you've got 43, which is going to go right here. 57 goes right here. 58, 68, 77, and then 89. So those are all going with those corresponding pieces. Okay, it says, and to predict how many cars will arrive over a 1-hour period. So this one we have 0, this one we have 0, this one we have 4, this is 1, and this is 1. Okay, and so then we have 0 times 0, 0 times 1, 4 times 2, 1 times 3, and then 1 times 4. So there's 0, 0 cars, there's 0 of 1 cars, there's a total of 8 cars. This one is 3, and this one is 4. So then 8 plus 3 plus 4 is going to give us 15. So then that's a total of 15 cars. Sorry. Okay, so we went through here and put our tick marks next to the assigned numbers, right? And so there were 4 here, so we do 4 times the number of cars that went during that period. So 4 times 2, which is 8. 1 times 3, which is 3. 1 times 4, which is 4, and then you add those numbers together. Okay, so now let's look at number 5. A set of data has a mean of 68 and a standard deviation of 6. Find the z-score of the value 39. Okay, so when we are looking for the z-score, remember it is value minus the mean all over your standard deviation. Okay, so that is value minus the mean over the standard deviation, if you wanted to look at it from that perspective. Now, the value in this case is 39. The mean is 68. And your standard deviation is 6. Okay, now when you put this into the calculator, I strongly recommend that you put the numerator in first and simplify that. So we've got 39 minus 68, which is negative 29. And then that's all over 6. So then we have negative 29 divided by 6, which is going to give us negative 4.83. And that will be your z-score. Okay. All right. Looking at number 6. The table shows the results of a survey of college students. Find the probability that a student is taking a humanities class given the student is male. So given that the student is male is the conditional part of the probability. That means we are only interested in the male students. So we add up the total number of male students. We've got 50 plus 60 plus 70. I don't know why I did it that way, but we're going to go with it. So that's 180. There's a total of 180 male students. And then it says that they are interested in, or they are taking a humanities class. Well, there's 50 taking a humanities class. So that would be 50 out of 180. And then you just put that into the calculator. And that gives you 0.27 repeating. And it said round to the nearest thousandths. So this is 0.278. Okay. Okay, for number 7, find the mean, median, and mode of the data set. So for number 7, you are going to enter this data into the graphing calculator. So we are going to stat, edit. I'm going to clear this list, and now I'm going to enter in my data values. So I have 12, 1, 12, 15, 9, 9, 12, 14, 8, 15, and 5. Now I like to go back through and double check. 5, 15, 8, 14, 12, 2, ooh, I only got 1 9. 15, 12, 1, 12. So I'm going to add a 9 here down at the bottom. Maybe. All right, there we go. There we go. 2, 4, 6, 8, 10, 11. All right, so now I'm going to quit this, and we're going back to stat, calculate 1, and now this is going to tell me my mean, right? So that's 10.18. My median, I'm going to arrow down, and the median is right here. It is 12. And now as far as the mode goes, I have to go and look at my data values, and looking at these numbers, I have 12 listed 1, 2, 3 times. I have 15 listed twice, 9 listed twice. So the mode in this case is going to be 12. And that again is because that one occurs the most, mode and most. Okay, number 8, making a box and whisker plot of this data. So we are going to use the calculator again. We are going to put in these data values. I'm going to clear this data. I've got 12, 29, 16, 14, 19, 13, 24, and 16. All right, so because I don't trust myself, we're going to double check those. 14, 16, 29, 12. Okay, so everything's there. So I'm going to quit. So second, sorry, I know there's the glare, but I can't really do much about that. I apologize. So second mode to quit. And the last action I told the calculator to do was that one variable stats. So I just press enter and it updates that with my new data. So then I have all of this, but for a box and whisker plot, I just want to scroll down and then get this information. So I've got the 12. I'm going to keep this over here. Maybe scooch this over. Okay. All right. Sorry. I know it's losing its visibility. So we've got 12, 13.5. So I'm going to make a mark at 12, one at 13.5, 16, 21.5, and then 29. So I make a line at the minimum, quartile 1, median, quartile 3, and the maximum. And now the 3 in the middle get connected to create the box. And then the 2 on the ends create the whiskers. All right. And remember, that means that there's 50% of the data is between 13.5 and 21.5. All right. Number 9, find the interquartile range of the data, round to the nearest tenth. So we are using the graphing calculator for this. You don't have to, but it certainly helps speed up the process. So we're going to go into the edit function, and we are going to enter in these numbers. So I'm going to clear the numbers I have in there right now. And then that gives me 25, 42, 14, 6, 42, 41, 55, 5, 51, and 39. All right, so now I want to go to quit, stat, and I'm going to do the one variable stat. So you could go stat, calculate 1, hit enter, or just hit enter from above. My range, the interquartile range, is not here, but I have to scroll down, and I get the range from doing max minus the min. So 55 minus 5. So that's going to give me 50. And then the interquartile range is going to be quartile 3 minus quartile 1. So 42 minus 14. And that's going to give you 28. All right, number 10, we are finding the mean and the standard deviation. So again, we are just putting this into the calculator. Stat, edit, enter in the numbers. So we've got 9, 9, oh, whoops, stat 1. There we go. Okay, so I've got 9, 9, 9, 20, 10, 10, and 11. I'm going to quit the edit process, and I just need the one variable stats. So now I need the mean, which in this case is 11.14, and then the standard deviation is 3.7. So the mean is 11.14, and my standard deviation is the 3.68. All right, now let's take a look at number 11. Susan keeps track of the number of tickets sold for each play presented at the community theater. The mean is 124. So I'm going to go ahead and jot that down here. Mean is 124. And the standard deviation is 30. Within how many standard deviations of the mean do all the values fall? So I can either put these in order from least to greatest to find out, I'm sorry, not least to greatest. I can put these all in the into the list and then find my one variable stats to find my min and my max. Or I can just look at the numbers. 103, 97, 150. 150 so far is the biggest. 149, 115, 129, 61, 70, 149, 91, 168. So 168 and then 66. Now looking for the smallest, I remember seeing 61. Is there anything smaller than 61 here? No. So 61 would be my minimum. So this is my max and this is my min. All right. I want to see how many standard deviations I would need to go in order to include all of my data values. So if my mean is at 124, then one standard deviation above would be adding 30. So 124 plus 30 is going to give me 154. That does not include 168, so I would have to go a second time. And so I'm adding 30 to that number, and so that's going to give me 184. Or you could do 124 plus 2 times 30, which is 60. 124 plus 60 is 184. Okay, and then for one standard deviation below, I would do 124 minus 30, so that would give me 94. I guess I should have written that down. All right, and so that's 94. 94 does not include 61, so I'm going to have to do at least another one. So I'm doing 94 minus 30 is going to give me 64. That still does not include this one. So then that means I need to go out a third standard deviation, and that's going to end up giving me 34. Okay, so this side I would have 3, and this side I have 2. But remember, we cannot have them unbalanced. They have to be the same amount. I can't say 3 on one side, 2 on the other. So to be consistent, we can't say 2 because this one has to have 3, and 3 is bigger than 2. So we're going to say within 3 standard deviations, because this one had to go out 3, even though that one only had to go out 2. If we go out one more, then that still includes all of that data. All right, I know that's kind of abstract, but it's also not too bad, so don't overthink it. Number 12, in a survey, students were asked how important they felt their math studies would be in the real world. The response scale ranged from 1 to 10. 10 representing extremely important. Which sample was most likely the largest? So we're looking at our standard deviation. Remember, the smallest standard deviation usually responds or corresponds with the largest sample. So 0.6 is the smallest number. So sample B would likely be the largest because the standard deviation is the smallest. Okay. All right. Find the margin of error for the sample population given a sample size of n equals 600. So remember, the margin of error is equal to plus or minus 1 over the square root of n. This is my n. So then that means plus or minus 1 over the square root of 600. So I've got 1 divided by the square root of 600, and that's going to give me 0.0408. Right? And it said round to the nearest percent. So I need to move this 2 places into the nearest percent. That's going to just be 4%. So this is plus or minus 4%. Because the 0, that would make that 1. And since we're going to the nearest percent, 1 would tell us to round it down to the 4. Okay, a survey of 660 high school students found that 51% had a pet. And this is our N. Okay, so N equals 660. Find the margin of error, then round to the nearest percent. Use the margin of error to find the interval that is likely to contain the true interval population. So the first thing I need to do is find that margin of error. So that's going to be 1 over the square root of my sample, which in this case is 660. So I'm going to do 1 divided by the square root of 660. And so then that is going to give me, 1 point, or not 1 point, goodness, 0.0389. 0.0389. We need to move this 2 places, and this tells me to round up. So this would be plus or minus 4%. Okay, now we had 51%, but that's going to be 51% plus or minus 4% for the margin of error. So we're going to do 51 plus 4, which is 55, and 51 minus 4, which is going to give me 47. So then it's going to be between 55% and, I should have done it the other way, sorry, 47% and 55%. You typically do smallest to largest, okay? All right, we are not doing 15. Number 16, a set of data with a mean of 62 and a standard deviation of 4.4 is normally distributed. Find the values that are 1 standard deviation from the mean. So 62 is my mean, and my standard deviation is 4.4. So 1 standard deviation above is going to be 62 plus 4.4. So then that would be 66.4. And 1 below is going to be 62 minus 4.4, and that is going to give you 57.6. Yeah. All right, I'm going to double check my math because it's late and I don't want to mess that up. 62 plus 4.4 and 62 minus 4.4. All right, there we go. All right, so these would be the values that are 1 standard deviation from the mean. Okay, number 17, find the outlier. So we are putting these numbers in order from least to greatest. 16 looks to be the smallest. So we've got 16, then we've got 17, we have 18, so 16, 17, 18, 19, 21, 22, 23, 19, 21, 22, 23, and then we've got 36. Well, hopefully it's blatantly obvious to you that 36 is the outlier. When we look at the outliers, we're looking at the lowest value and the highest value. Between these two, there's only a difference of 1. Between these two, there's a difference of 13. So that means 36 is your outlier. Number 18, the numbers of cookies in a shipment of bags are normally distributed with a mean of 54 and a standard deviation of 5. What percent of bags of cookies will contain between 44 and 64? Okay, so if my mean is 54 and my standard deviation is 5, then to go from 54 to 64, that would be two standard deviations. 64 minus 54 would be 10. 10 divided by 2, or 10 divided by 5 is 2. Or you can look at your graph, right? And to do one standard deviation, that would make that 59 because you're adding 5. And then this would be 64 because you're adding another 5. And then we subtract 5, and that would give you 49. And then subtract 5 again, and that's going to give you 44. So between 44 and 64, this would be two standard deviations. We know that this number is 68. This number is 95, going from here to here. So that means 95% of the bags will contain between 44 and 64 cookies. Okay, number 19. The scores on an exam are normally distributed with a mean of 80 and a standard deviation of 8. What percent of the scores are greater than 88? So first thing I would do is sketch a normal curve. My mean is 80 and my standard deviation is 8. So I would go up one standard deviation. Adding the 8 would give me 88. And so that's what I'm looking for. Now it says greater than 88. So that means I'm looking for this side of the curve. I know from here, this is 50%. I know this is 34%. So 50 plus 34 is going to give me 84. And so then this part is 100 minus 84, which would give me 16%. Right? Number 20, use a sketch with a mean of 50 and a standard deviation of 5. Label the x-axis at 1, 2, and 3 standard deviations above and below, and label the mean too. So we have our standard deviation of 5, so I'm adding 5, that's going to be 55. Add 5, that's 60. Add 5, that's 65. Subtract 5 from 50, and that gives you 45. Subtract 5, that gives you 40. Subtract 5, that gives you 35. Okay, and don't forget the 68, 95, 98 rule. Okay, so 68, 95, and then 98. Right. The probability that a city bus is ready for service when needed is, I'm going to focus that real quick, is needed is 77%. The probability that a city bus is ready for service and has a working radio is 67%. Find the probability that a bus chosen at random has a working radio given that it is ready for service. All right, so we are saying given that they are ready for service. Well, there's a total of 77% who's ready, so 77 out of 100. So that means we have a total of 77 are ready, and then there are 67 that are ready with a radio working, so it's 67 out of 77. So you do 67 divided by 77, and that is going to give us 0.8701. And looking over here, it says round to the nearest 1/10 of a percent. So I move that 2 places, and that's going to give me 87.0%, or just 87%. Okay, the last thing that we have, in a sample of 136 teenagers, 20 have never been to a live concert. Find the sample proportion for those who have never been to a live concert. So 20 have never been out of a total of 136 teenagers who were asked. So then 20 divided by 136 is going to give me 0.147. This one doesn't specify whether to the nearest decimal or percent, so your answer, just leave it as a decimal and you'll be good. Okay, so that is all 22 questions. I hope I didn't go too fast. If I did, rewind, replay. And if it still doesn't make sense, give me a call. Don't give me a call. Send me an email and I will help you out with that. Don't forget that you can come in before school on Thursday, and you can ask to come in during advisory on Thursday if you're in 7th hour, and I will be more than happy to help you out with this. All right, good luck and have an awesome day.